2.7, the addition rules for probability. Two events are what we call mutually exclusive if they cannot both occur at the same time. That is, the events have no outcomes in common. Let's look at exercise 1. In drawing cards from a standard deck, decide if the two events are mutually exclusive or not. If not, list all outcomes that the events have in common. First one is drawing a 5, drawing a 6. Well, mutually exclusive means they cannot both occur at the same time, and I don't know of any cards in the deck that are both 5s and 6s, so this would be mutually exclusive. You are either a 5 or a 6. There's not a card that's both 5 and 6. Part B, drawing a 5, drawing a heart. Well, I know of a card called the 5 of Hearts. So that means that both of these things can happen at the same time. This is not mutually exclusive. And again, the event that it has in common would be the 5 of Hearts. Part C, drawing a black card, drawing a face card. Well, you can draw the Jack, Queen, or King of spades, or the Jack, Queen, or King of clubs. And that would be both a black card and a face card. So again, this is not mutually exclusive. In other words, these things can happen at the same time. Addition rule number 1. When two events, A and B, are mutually exclusive, the probability that A or B will occur is the probability of A plus the probability of B. For example, exercise 2. A bakery has 3 pieces of chocolate cake, 5 pieces of carrot cake, and 4 pieces of red velvet cake left in its dessert case. If a customer selects at random one kind of cake for dessert, find the probability that it is either carrot or red velvet. For starters, the piece of cake that you pick is never going to be 2 flavors. So I'm never going to have a piece of cake that's both carrot and red velvet. So this event that we're talking about is mutually exclusive. Because it's mutually exclusive, addition rule number 1 applies. So the probability of getting a piece of cake that's red velvet or carrot will be the probability of getting a piece that's red velvet plus the probability of picking a piece that's carrot. And again, I'm just using the addition rule. Well, I have 3 pieces of chocolate cake, 5 pieces of carrot cake, and 4 pieces of red velvet cake. So in total, we have 12 pieces of cake, or you can think of this as our n. So the probability of getting red velvet is going to be 4 out of the 12. And the probability of picking carrot is going to be 5 out of the 12. Adding these together, they have that common denominator of 12. So I have 9 out of 12, or 3/4. So the probability that the piece of cake that you pick is carrot or red velvet is 3/4 or 75% chance. Exercise 3. In rolling 2 dice, find the probability that the sum is 2, 3, or 4. I think this problem would be helpful if we wrote out the sample space. I want to know how many different outcomes there are when rolling 2 dice and adding up the numbers on the dice. Well, I know that for my first die, I can either roll a 1, a 2, a 3, a 4, a 5, or a 6. And for my second die, I can get a 1, a 2, a 3, a 4, a 5, or a 6. So one outcome that could happen is I could roll a 1 and a 1. My first die was a 1, my second die was a 1. Or maybe my first die was a 1, but my second die was a 2. Or my first die, I rolled a 1, and on my second die, I rolled a 3. And I can continue this pattern where I roll a 1 and a 4, or maybe it was a 1 and a 5, or a 1 and a 6. But maybe on my first die, I rolled a 2, and on my second die, I rolled a 1. Or I rolled a 2 on both dice. Or I rolled a 2 and then I rolled a 3. If you continue this pattern, you can write out all of the different outcomes for rolling 2 dice. And you should be left with all of these outcomes, or notice I have 6 by 6, so I have 36 different outcomes in this chart. We were asked to find the probability that the sum of the numbers on the 2 dice are 2, 3, or 4. So the probability that we get a sum of 2, 3, or 4. Okay, well, let's look at our chart. So the only time I see me getting a sum of 2 is when I have 1 and 1. So the probability of getting a sum of 2 is going to be 1 out of 36. Now let's talk about the probability of getting a sum of 3. Well, that can happen when you roll a 2 and a 1, or a 1 and a 2. So that's 2 of my 36 different outcomes. And lastly, let's find the probability of getting a sum of 4. That can happen when I roll a 3 and a 1, or a 2 and a 2, or a 1 and a 3. So 3 of my 36 outcomes. In total, the probability that I get a sum of 2, 3, or 4 is 1 plus 2 plus 3, which is 6 out of my 36 outcomes, which simplifies down to 1/6. So there's a 1 out of 6 chance that the sum on the 2 dice will be 2, 3, or 4. Addition rule number 2. When two events, A and B, are not mutually exclusive, the probability that A or B will occur is the probability of A plus the probability of B minus the probability of A and B. Let's look at exercise 4. 2 dice are rolled. Find the probability of getting doubles or a sum of 6. It might be helpful to use the exact same sample space that we used for problem 3, so let's go reference that again. So problem 4 asked for the probability of getting doubles or a sum of 6. Well, you can get doubles if you roll a 1 and a 1, a 2 and a 2, a 3 and a 3, 4, 4, 5, 5, or 6, 6. But it also asks for sum of 6. Well, 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, and 1 plus 5 is 6. So, the probability of getting doubles or a sum of 6 will be equal to the probability of doubles plus the probability of a sum of 6. Well, hopefully you noticed while I was circling that there was one of our 36 outcomes that was circled twice, and that was where we were both a double and a sum of 6, which was the case 3, 3, right? When I roll 3 and 3, it's a double, and when I add 3 plus 3, it equals 6. So I added that one too many times. So for the doubles, I have 6 options out of my 36. For the sum of 6, I have 5 options out of 36, and then I have one option that I counted too many times, so I need to subtract it off once. So we have 6 out of 36 plus 5 out of 36 minus the doubles with 3, 3 because I added it one too many times. Adding and subtracting these, I end up with 10 out of 36 or 5 out of 18. So the probability of getting doubles or a sum of 6 on your 2 dice is 5 out of 18. Problem 5. In a liberal arts math class, there are 15 freshmen and 10 sophomores. 6 of the freshmen are psychology majors, and 4 of the sophomores are psychology majors. If a student is selected at random, find the probability that the student is a sophomore or a psychology major. Let's fill out this chart together. Well, for starters, it says that we have a total of 15 freshmen. So for freshmen, I should have a total of 15. And a total of 10 sophomores. So in my sophomore column, I should have a total of 10. And if I add these together, I have a total of 25 students. Out of my 15 freshmen, 6 of them are psychology majors. And out of my 10 sophomores, 4 of them are psychology majors, for a total of 10 psychology majors. But I know I have 15 freshmen and I've only accounted for 6 of them, so that means 9 of them are non-psych majors. And out of my 10 sophomores, I've only accounted for 4 of them, so 6 of them are not psychology majors. Or in total, I have 15 students who are not psych majors. The question is, if a student is selected at random, what's the probability that they are a sophomore or a psych major? I'd like you to try this problem on your own. So pause the video give it a go, and then come back and check your work. So the probability of being a sophomore is 10 out of my 25 students. The probability of being a psych major is 10 out of my 25 students. But notice that I counted my 4 sophomores who are also psych majors one too many times, so I need to subtract it off once, because I already accounted for these 4 people in this group and this group. Then adding and subtracting the numerators over the common denominator, you should get 16 out of 25.